Okay, so in 6.4, we're not looking at anything new. All we're going to do is summarize section 6.1 through 6.3. So we're going to give ourselves a summary of factoring. I am not going to say anything in the next several minutes that's different than what you already know. Well, that is kind of hard to see, isn't it? Let's see if it can. Let's try this just a second. Let's pause. So, here's what you already know. You know that the first thing we're going to do on any factoring problem is look for a common factor. So every time we get something to factor in this chapter or moving forward, that's the first question we ask. Is there a common factor? If there is, we factor it out. If there's not, we just move on to the second step. The second step, you know, is we need to ask how many terms. The number of terms determines the strategy for factoring. If there are 4, that means we do grouping. If there are 3, that means we're going to do the AC method. And not only that, but it also means that if there's a 1 on the squared term, we'll use the shortcut. And if there are 2 terms, we have to check first to see if we have the difference of squares. And if it's not that, then we'll check to see if it's the sum or difference of cubes. Okay, so let's work through that line of questioning on the following problems. I picked 1, 2, 3, 4, 5, 6, 7, 8 problems for us to look at. Here's the first one. 9p plus 45. David gets his test, so the first thing he asks is there a common factor? And out of 9 and 45, there is. 9's a common factor. So take the 9 out. 9 factored out of 9p leaves us with p. 9 factored out of 45 leaves us with 5. Okay, but then we always need to see if we can factor what's left inside the parentheses. It has 2 terms. So the first thing we need to check is this the difference of 2 squares? It's not that, because first of all, it's not a difference. It's an add. So then we need to ask if it's the sum or difference of cubes, but it's not that either, because p is not being cubed, and 5 is not a cube number. So there's not any more we can do with it. So we are finished. 9 times the quantity, p plus 5. That's not too bad. Okay, here's the next one. 64m squared minus 9n squared. I'll let you guys get a step out in front of me, and then I'll catch up in a moment. That's what I decided. I looked at this problem and said there is no common factor. Then I counted the number of terms and got 2. So I checked to see if this is the difference of squares. And it is. 64 is a square number, and so is 9. So, and m is being squared, and so is n, and it is indeed a difference. So 64 will go 8m and 8m. 9n squared will go 3n and 3n. And one of those gets a plus, it doesn't matter which one. The other one gets a minus, it doesn't matter which one. And we're finished. 8m minus 3n, 8m plus 3n. The difference of squares. Alrighty, let's take a look at this one. P squared plus 10p plus 25. First question is there a common factor? The answer is no. 25 doesn't have a p, and the only factor of the coefficient on p squared is 1, so obviously we're not going to have a common factor other than 1. So it's got 3 terms, so that means the AC method. But in this case, we can use the shortcut because the coefficient on the p squared is 1. So let's recall the shortcut. 1 times 25 is 25. Looking for 2 factors of 25 that add up to 10. 1 times 25 and negative 1 times negative 25 are a factor pair of 25, but they don't add up to 10. 2 doesn't go into 25. 3 doesn't go into 25. 4 doesn't go into 25. 5 does go into 25 5 times. So either 5 times 5 or negative 5 times negative 5. But 5 times 5 is the one that adds up to 10. So how does it factor with the shortcut? Remember, the first 2 blanks are always P and P, or X and X, or Y and Y. And then whatever the factor pair is goes in the last 2 blanks. So this factor is P plus 5 times P plus 5. If you give that to me, I'll be happy. That's a good answer. Sometimes your book will write, when it has repeated factors like this, as P plus 5 squared. That also is a good answer. So either one of these are good. They're okay. I'm not putting check marks because they're wrong. I'm putting check marks because they're right, actually. Well, 3 down. Let's look at this next one. 8. No, hang on. Let me think for a minute. Let's go with 125 x cubed plus 216. Is there a common factor? And this one's kind of hard to see because the numbers are bigger. If you start thinking about the factors of 125, you're going to get 1 and 125. And 5 is going to go into it because it ends in a 5. 5 goes into it 25 times. And that's about where it's going to end. So the factors of 125 are 1, 5, 25, and 125. None of those go into 216. So there is no common factor. So I'm going to count the number of terms. There are 2. But this is not the difference of two squares. It's not a difference, and those numbers are not square numbers. Okay, then I need to ask if it is the sum or difference of cubes. And it is. 125 is the cube number for 5, and 216 is the cube number for 6. So if it's a cube problem, we've said more than once now that the first thing we want to do is write it as something cubed and something cubed. And the two things that we would cube here are 5x and 6. Now you work out in front of me again for a moment and I'll catch up to you and we'll compare notes. Okay, so hopefully what you did next is you said, well, the A is 5x and the B is 6. And the other three things I need on a cube problem are always a squared, ab, and b squared. A squared would be a times a, or 5x times 5x, which would be 25x squared. AB would be a times b, or 5x times 6, which would be 30x. B squared would be 6 times 6, or 36. So, what's my answer? My answer is a plus b, 5x plus 6, times a squared minus ab, minus 30x, plus b squared, or plus 36. And that went off the screen over there. There we go. So this is our solution over here in red, our answer, I should say.
One of the other things I always do first is do the...
Okay. What's next, Mr. Black? Well, let's just keep going here. I got 49z squared minus 42z plus 9. Let's look to see if there's a common factor. The factors of 9 are 1, 3, and 9. Let's check out 3. 3 actually goes into 42, but it does not go into 49 evenly. So that doesn't work. Let's check out 9. Well, 9 doesn't go into 42. So what are we saying? There are no common factors. There are 3 terms. So we're going to do the AC method. We cannot use the shortcut because we do not have a 1 on the squared term. We've got a 49. So we're going to have to do AC method old-fashioned way. So let's take 49 times 9. If you do that, 49 times 9 is 441. I don't know why it just did that, so I'll have to, just did a whole bunch of stuff. Hang on here. Oh, it's there, okay. So we got to try to find 2 factors of 441 that add up to negative 42. Okay, well here's what we've been doing. We've just been starting at 1 and going up. So 1 times 441, or negative 1 times negative 441, but golly, neither one of those add up to 42, or negative 42. 441 divided by 2 is a decimal, so 2 doesn't go into it. 441 divided by 3, I'm checking these on my calculator. 3 actually goes in 147 times. So 3 times 147, or negative 3 times negative 147. But those sure don't add up to negative 42. By the way, when you have an odd number, like 441, an even number cannot go into an odd number. So 4 is not going to go into it. 5 doesn't go into it because it doesn't end in 5. When I divide it by 5, I get 88.2, so that's no good. 6 doesn't go into it. 441 divided by 7 is 63. Let's try that. 7 and 63, or negative 7 and negative 63. You're going to get negative 42 out of either one of those? Nope. 8 doesn't go into it. It's even. Let's check 9. 441 divided by 9 is 49. Let's try that one. 9 and 49, or negative 9 and negative 49. But those add up to 58 and negative 58. So neither one of those are it. Guess we'll just have to keep going. 10's not going to go into it because it's even. 11 gives me a decimal. 12 is even. 441 divided by 13 is a decimal. That's no good. 14 is even. That's not going to work. 441 divided by 15 is a decimal. That's not it. 16 isn't going to work. 441 divided by 17 is a decimal. That's not it. 18 is not going to work. 441 divided by 19 is a decimal. That's not going to work. 20 is even. That's not going to work. 441 divided by 21 is 21. Well, isn't that interesting? 21 times 21, or negative 21 times negative 21. That's our last hope, because we know we're going to flip-flop on the next one. The two sides are going to flip. But negative 21 and negative 21 add up to negative 42. So it took us a while, but we got there. So 49z squared minus 21z minus another 21z plus 9. Now we'll do grouping. Don't forget that the minus has to stick with the 21. We'll stick a plus sign in there to show that they're still being added. What do you guys want me to take out of 49z squared and negative 21z?
7z.
Okay, 7z out of 49z squared is going to leave 7z. Out of negative 21z is going to leave negative 3. That means back here we'd like to be left with 7z minus 3 again, which means the two signs are going to have to flip for that to happen, so I got to have to factor out a negative. And out of 21 and 9, I could factor out a 3. Negative 3 out of negative 21 leaves 7z. Negative 3 out of 9 leaves negative 3. So how's it factor? 7z minus 3 times 7z minus 3, which is a good answer. Or if you wanted to, you can do 7z minus 3 squared, which is also acceptable. Mr. Black, that took a while. Yeah, it did. Sometimes they do. Sometimes they do, class. If it was easy, everyone would have a degree. 2 more. Here's the first one. xy squared minus y cubed plus x cubed minus x squared y. Is there a common factor? The answer is no. Some of them got x's, some of them got y's. They don't all have the same thing. Okay. There's 4 terms. 1, 2, 3, 4. So we know that we're going to have to do grouping. Anytime there's 4 terms, we're going to try grouping. Out of xy squared and minus y cubed, we could take out a y squared. Y squared out of xy squared leaves x. Y squared out of y cubed leaves y. And out of x cubed and x squared y, we could factor out an x squared. X squared out of x cubed leaves x. X squared out of x squared y leaves minus y, and we got what we wanted because those two are identical. So in our answer, we're going to have a factor of x minus y and a factor of y squared plus x squared.
Just not on this.
Okay. Last problem I have picked out for this section is 25m squared plus 121. If I look for a common factor, the only things that are going to 25 are 1, 5, and 25. None of those go into 121. So, we do not have a common factor. We have 2 terms. So we should check to see if this is the difference of 2 squares. Class, this is not the difference of 2 squares. It would be because 25m squared is 5m times 5m. And 121 is 11 times 11. The only thing that keeps it from being the difference of 2 squares is it's not a difference, it's a sum. We don't have a formula for the sum of 2 squares. So therefore, this polynomial is prime. It will not factor. Again, if that was 25m squared minus 121, then it would factor as the difference of 2 squares. But it's not, so it won't. Okay, now, last thing I'm going to say about factoring for the time being. I said you have to get chapter 6 or you're not going to get chapter 7. Because when we go to do rational expressions and equations, you have to be able to factor to do what we want to do there. So we don't want to just be okay at this, we want to be great at this. With that in mind, here is your assignment. Page 342. 2 through 23 every third. And then jump over to 29 and work until number 47 every third.